All right, the next session is going to be about the future of, most likely what I think will be the future of U.S. government credentials, with talking about derived PIV. Christopher Brown from the Mitre Corporation is going to fill us in on what the NCCoE is doing with derived credentials and PIV. Thanks, Christopher.
Thanks a lot. So I am from the Mitre Corporation. We support the National Institute of Standards and Technology. Is it not? Okay. So we support the National Institute of Standards and Technology, NIST. If you're not familiar, NIST is a U.S. agency. And they come up with a lot of the technical standards for federal agencies. And so specifically within NIST, there's a organization called the National Cybersecurity Center of Excellence, NCCoE. This was started a few years ago, and so it's kind of the applied arm of NIST. And the goal of the NCCoE is to accelerate the adoption of secure technologies, or cybersecurity technologies. And so we do that through a variety of projects at the NCCoE. We engage with a lot of U.S. sectors to find out what their biggest cybersecurity issues are. And so we have projects with the energy sector, financial sector, health sector, and we engage with these industries and find out what their cybersecurity problems are, and we bring them back to our labs at the NCCoE. And so we put together these reference architectures in our labs, and we put out what's called practice guides. And so practice guides come out as NIST special publications, if you're familiar with those, 1800 series. And so we detail everything we do within these projects to solve these particular cybersecurity problems. And so they're addressed to different audiences. One's addressed to a C-level type person in your organization. And another part of it is a how-to guide, where we detail exactly what we do with products to solve these different problems. So yeah, one of our projects at the center is around mobile authentication in the government with Derived PIV, which I'll talk about more. So yeah, let's get into it. So this is an image of a PIV card. This is my PIV card. So this is what federal employees and contractors in the U.S. federal government get as their identity credential. So this was started years ago with a presidential directive, HSPD 12. And what that said was U.S. federal employees and contractors should have a common credential throughout the federal government. And so this is backed up by NIST technical standards, FIPS 201-2, and several special publications that kind of detail the technical implementation of the PIV card, which I'll get into a little bit. And so when you get a PIV card, you're actually issued some PKI certificates that go along with it. There's an authentication key, obviously used for authentication. Digital signature, used for things like signing your email, things like that. Key management key, so people can encrypt things to you, and a card authentication key. And all these are defined within NIST special publications. And there's some other things stored on the PIV card, such as a digital representation of your face, fingerprints, optionally an iris scan. So there are a lot of things defined that can be stored on the PIV card. And so this is an image of the PIV lifecycle. I won't go through all the details, but I really wanted to focus in on the identity proofing and registration part of it. There's a really large investment in the federal government in this piece of the issuance of the PIV card. There's some background checking. There's some strong identity proofing that goes on in order to get your PIV card, which makes this a very strong credential for federal employees. So it makes sense to leverage this investment in the identity proofing and vetting if you want to use this to get other credentials. So for years now, with the PIV model, you've been able to use your PIV card with laptop devices. So you're issued a laptop, it has a smart card reader, you're able to use it. Usually you don't have to install any special drives or anything, it's just ready to go. And you can use it for things like authentication to your network domain or authentication to websites, things like that, and it pretty much works. And you can also use it for physical access to spaces as well. And so this model has worked for years now. Obviously, the world has changed quite quickly in the past few years. Federal employees are issued mobile devices, which do not have PIV card readers, so this makes strong authentication difficult to federal systems. We still want to maintain strong authentication to federal systems with mobile devices, so this problem comes up. And so we know in modern times, federal employees get things like mobile devices in the form of phones, also hybrid tablet devices. So there are many types of different devices out here. And they're running different operating systems. There are Android phones, iOS devices. That's a Windows Surface right there. So there's a lot of diversity there. So there have been some attempts to try to leverage PIV cards for strong authentication with these mobile devices. And so this is one attempt that you may have seen. So this is a dongle that kind of hangs off your mobile device. But as you can see by the picture, it's pretty awkward to use. So there's this thing hanging off. There are battery issues. And there's also, you have to compile applications to specifically talk to these PIV card readers. And from what I've heard, they're expensive as well. So this is one solution. Doesn't work great, but it can work. There's also been prototypes and pilots to contactlessly leverage the keys on the PIV card through the NFC channel. This has some issues as well. You have to create a secure channel to the card itself, which is not baked into the mobile device operating system. So you kind of have to bake all these things into your application. And up until recently, the NFC radio was only available to Android devices. Recently, I read that iOS 11 opened up the NFC radio, so maybe this is an option in the future. And so a few years ago, NIST put out special publication 800-157, which defines the derived PIV credential. So this special publication goes through what it is. It's an X509 certificate that lives on your mobile device. It goes through where you can store it, the different type of crypto tokens that can store the device, and it also defines the life cycle. And you see in this diagram here, again, I won't go through the details, but there's a linkage between your derived PIV and your PIV card, such that you need to have a valid PIV card before you can be issued your derived PIV on your mobile device. And there's also some other linkages there. So when your PIV card is terminated, there has to be a linkage between your derived PIV issuer and your PIV issuer to terminate your derived PIV when your PIV is terminated. And you can read more about that in the special publication 800-157. But I wanted to bring us up to the project that's going on at the NCCoE. We took on this project to demonstrate how you could use derived PIV credentials within federal agencies. This is kind of a special case project at the NCCoE in that it targets the federal government, the U.S. federal government, but any organization can use this sort of solution if they use some sort of smart card credential to leverage that to get mobile strong credentials. And so we started this project about a year ago, and like I said, we work with commercial off-the-shelf products at the NCCoE, so we partner with different organizations to put together a couple of different architectures that federal agencies can use, and I'll get into those as I move along. So like I said, we are demonstrating how derived PIV credentials can be added to mobile devices. The big goal of this project is to demonstrate the lifecycle management requirements of derived PIV. So The specification itself goes through the issuance, maintenance, and termination of the derived PIV. So in the issuance portion, you have to prove possession of your PIV card before you get issued a derived PIV. With maintenance, it goes through such cases as what happens when you have a name change. How do you get your certificates updated? What happens if you lose your mobile device? What happens then? Things like that. And of course, termination. What happens when you no longer need this credential on your mobile device? We go through all those use cases in our project. And secondarily, we're demonstrating mobile applications' ability to leverage the derived PIV to use it to authenticate to different applications. Like I mentioned, at the NCCoE, it's important that we use commercial off-the-shelf products. And so these are the companies that we're partnered with. We sign what's called CRADAs with these companies, and they agree to donate their services and technologies to us. And so we're working with these companies to create our architectures. And I'll get into what each company is contributing in the next slide. So to put together an architecture for derived PIV, there are different components that you need. And so on the left is kind of the different buckets of components that we use for to putting together an architecture. So the first one is PKI. This is the entity that actually issues the certificate onto the mobile device. For that, we're using a cloud service and trust managed PKI. Cryptographic token. This is where you actually store the token. According to the spec, it needs to be a FIPS-approved crypto module. And so we're working with Intel Authenticate, which bakes it into the processor itself. GoTrust Encryptor, that's with their solution, it may be potentially possible to get level of assurance 4. But specifically in this project, we're working with software containers that live on the mobile device for this first phase. Third, the credential management system. So this is what manages the life cycle of your PIV card and your derived PIV. For that, we're working with Interseed and Entrust, which is another cloud service that I'll talk about a little bit later, and Xtech. And something we added, enterprise mobility management. In modern organizations, if you have a mobile device issued by your work company, you're probably familiar with it being managed with security policies and things like that. So we've added this to the project to make it more applicable to real life. And I want to go through the two architectures that we've come up with in our labs that we're putting together. So this one features Interseed. So there's an on-premise credential management system that manages the PIV and derived PIV lifecycle. And there's some back-end resources there. To actually issue the certificates, our Interseed system is integrated with Entrust Data Card's cloud services. And on the mobile device, Interseed has some mobile applications that we're leveraging. So there's an app that helps you work through the workflow of actually getting a derived PIV. And there's some, and they have apps that are that can leverage the derived PIV through a software development kit. So there's a browser, and you can browse to secure sites that are PIV enabled with your derived PIV. In our second architecture that we're putting together, we're working mostly with Mobile Iron and Entrust. So if you're familiar with Mobile Iron, they're big in the mobile device management space, and they've tightly integrated with the Entrust derived PIV management service. And so we have this workflow where a federal employee could enroll their mobile device with Mobile Iron and at the same time get their derived PIV. And this, again, uses a software container that Mobile Iron provides that Entrust has integrated their crypto token with. And so this has apps like email. You can digitally sign email with your derived PIV, a browser, browse to different websites that are PIV enabled, things like that. So that's kind of a very high-level view of the two architectures that we're building out in our labs. So to talk about outcomes of the project, we're engaging with federal agencies. So For the past few months, we've had agencies come through the NCCoE and talk to us about the problems that they're having, so we can bring them into our project and learn about them and potentially use them in a future phase of the project. We're learning lessons from different pilots and implementations from other federal agencies that are trying to implement this. The third point there is pretty important. We're collaborating with our COTS vendors, so the Entrust, Intercedes. We're collaborating with them. So what that means is if we find a problem or something like that, they can issue a patch in their software and get it to us very quickly so we can test it out in our labs. So federal agencies don't have to go through these problems. And the publication of a practice guide. Like I mentioned earlier, the output of these projects is a practice guide. And so we're going through the process of documenting the architectures, the configurations, everything that we're doing in this project, and so that outside organizations can leverage them. And they don't have to go through the trouble of learning all these lessons learned on their own. So I wanted to finish up here with some challenges that we've heard from agencies. So like I mentioned earlier, there are a lot of options for credential storage. They can be embedded in devices, and this is often complicated by the level of assurance that the federal agency wants to achieve with their derived PIV. So just to go through a few examples here. This is GoTrust, who we're working with. They have a micro SD solution that can go into mobile devices. But here you have the problem of you needed a device that has a micro SD slot, which is usually just Android devices at this point. On the right there, you see an adapter that you can use with iOS devices, but still you're using an adapter, which might not be the most ideal kind of solution. 800.157 also defines UICC or SIM card as a crypto token storage device for derived PIV, which seems like the perfect solution, but you have to work with the carriers to actually access the SIM card, so that can be problematic. You can also use these little USB tokens with a hardware-based crypto token in them. This is good, but they're really tiny and can be lost. And you also need to have a software development kit to program to it so you can actually leverage the derived PIV. Another option is in embedded solutions. So there's a trusted execution environment that's defined by the ARM processors. And Qualcomm has a implementation of that with their Snapdragon processors. So this is an option that agencies can use, but there can be some issues with even doing this. And even Apple has their solution with Secure Enclave, and that's their solution to natively storing credentials on mobile devices. So there are a lot of different options here. And also finishing up with software containers. Now this is often the quickest way to implement derived PIV within organizations because it's all software based. It lives on the mobile device with a container. You can roll it out with an EMM. So this is often the quick and dirty way to do it, and the way that we're exploring with the first phase of this project. So there's no standard interface for applications to access the credential stores to actually use the derived PIV. So this is an example from our MyID partner. They have a software development kit that you have to use to actually use the derived PIV. So you can see this is, it's not complicated, but it's just a specific way you have to use their software development kit to actually use their derived PIV in their software container. And if you go the native route, storing it natively on the mobile device, Android, of course, has their way of accessing the hardware-backed key store, and iOS has their keychain access. So if you have applications that need to be updated to use derived PIV, there's a lot of different options here that you might have to consider within your organization. Expanding the vendor ecosystem for derived PIV. So right now, there are only a few companies who actually are derived PIV capable and able to fulfill all the requirements of 800.157. So we're looking to expand that and increase the competition. So that's always good for federal agencies. Integration with current PIV cloud services. So currently, a lot of agencies use US Access, which is a GSA service, to manage their PIV cards. But right now, that service isn't Derived PIV aware, I would say. So we're working with them to maybe update their APIs and interfaces to be Derived PIV aware, such that agencies can use it in their organization without having different organizations manage their PIV card and their Derived PIV. And newer authentication protocols are becoming mature. And what I mean by that, so FIDO, that has a big presence here, we could investigate whether there's some intersection between those protocols and Derived PIV. We know that these protocols are being baked into mobile devices natively, so maybe that's an easier way to go with Derived PIV. But right now, the 800.157 specification only allows X509 certificates to the mobile device for strong authentication. So in the future, that may change, but this is the point where we're at right now. So I will end it right there if there are any questions.
Great,
Sure.
thanks. Steve, I'll let you go first.
Okay, cheers. Two quick questions. One, does the PIV derived framework allow for additional digital certificates to be loaded? Because I think one of my frustrations has been the original HSPD12 and PIV family kind of was very restricted to just 3. And the related question is, are you working with this for beyond authentication, but to apply digital signatures using PIV credentials as well?
Yeah, so what I didn't mention is, yes, the specification allows for digital signature certificate and other types of certificates as well. But the first one that you get is the Derived PIV, which is the authentication certificate. So yes, and actually in one of our implementations, we recover your encryption certificate from the PIV card, so that you can decrypt, let's say, email on your mobile device. So that's another option.
Are there any specific applications you guys are focusing on out of the gate for it?
So in this phase of our project, we're really focusing on the life cycle of the Derived PIV, so the issuance, maintenance, and termination. In the future, we're listening to the agencies to, basically, we want them to tell us what to focus on. So obviously, browser-based authentication, email is another big one. Maybe VPN authentication are things that we've heard that we should tackle in the future.
Great. Other questions? Well, sorry.
Will the scope of what you're working on and going to be writing up include the discussion about how interoperability through the bridge at different levels of assurance and mapping maybe to the secure elements on the phone will look like? I mean, that's my biggest struggle, is trying to understand how we achieve something that we can interoperate with at an adequate LOA.
Right.
And with the different platforms, phones, I'm talking about,
Yeah.
in the way they change, that seems to be the part that's the most mysterious.
Right, yeah. So that's something we've heard. So we will include a table that will map the level of assurance that you get with the particular technologies that we used in the project. You can also look at, this actually builds on a previous project by NIST, which is documented in NIST IR 8055. You can check that out. And there's a mapping in there that's pretty helpful. But yeah, that's something we plan to document.
Hi, this is probably more really a question for the computer security division, but it's just going to your very last bullet that you closed with. Mm-hmm. And I'm more interested if you have any insight to where they are. I know Paul Grassi himself has blogged on the usage of FIDO as a PIV alternative. Mm-hmm. It's very easy to conceive that the PIV card could still be used as a U2F authenticator, or that UAF could be used in place of the derived credentials, which would solve a lot of the things you were looking for. For example, the marketplace and vendors. There's a plethora of people in the FIDO Alliance. I'm just curious more if you know what's going on, have any insight into the CSD part of NIST?
Yeah, I don't personally have any knowledge there. Yeah, just as we may tackle something like that at the future at the center, but no plans just as yet.
Other questions?
Yes, up front.
Oh, sorry.
So earlier slide you mentioned about the ID proofing.
Mhm.
So what kind of service, like is it online or personal validation in person? What kind of ID proofing service are you using?
Right, so we're, are you talking about, well, the ID proofing for the PIV card, initially, that's defined in FIPS 201. So there's, I think you need 2 forms of identification, your license and passport or something like that, in order to get your PIV card. For your derived PIV, it can be remotely issued. So what you would do is use your PIV card to authenticate to maybe a website or something. You use your PIN to unlock the PIV card that proves proof of possession of it. So you have that strong binding there to your PIV card, and so you're able to be issued the derived PIV onto your mobile device. If that answers your question. But if you want details on the ID proofing, it's in FIPS 201.
So you kind of broadly mentioned the federal agencies. I'm curious, is Department of Defense included as one of those federal agencies? And if yes, do you have any insight into what the future state of the CAT cards is going to be? Is this potentially an alternative that the CIO discussed?
Oh, we've had a little bit of discussions with DoD, but they're kind of doing their own thing, so it's a little unrelated. But yeah, I know they do have a mobile credential type project that's very similar to the derived PIV concept.
I've got a question on just the validation and evaluation. So there's a lot out on 157, but there's not a lot of guidance on how actually the labs can actually do the complete evaluation and the certification. So all the products right now, I mean, are not really certified in any shape or form. So we've talked to a few labs. They have no clue how this actually go through actual certification program. So what's the thought process there, given that specs, SP's out, but no lab can actually do any certification on this?
So I want to make clear that NCCoE doesn't certify anything, or we're not saying that we're not a certification agency. I don't know the answer to that as far as specifically certifying something that it adheres to 800-157. I'm not sure if that will happen or not. So.
Other questions?
I just have one. Is there any talk of getting the vendors to come to some sort of a standardized manner to which to integrate what happens in your card issuance management system and your derived credential management systems? Or is this always going to be something proprietary?
So the specification kind of speaks to that. It gives out some examples that you can use to communicate with each other. But I think right now it's pretty proprietary and one-off type solutions. Whether we get to a standard, I'm not sure, but that's something we would definitely encourage at the NCCoE. So.
Are you familiar with the Federal Bridge?
Yep.
Okay, so are you working with the Federal Bridge for actually being able to work with the vendors that provide PIV credentials to their contractors through services?
Yeah, so I actually mentioned that Entrust, their managed service, they're one of the PIV certificate providers, and we're working with them. So yeah. Was that?
And Symantec.
No, we're not working with Symantec at this point.
Great. Christopher, thanks so much.
Thanks.